In this video, I'm going to find the critical numbers of the following functions. So first recall that c is a critical number of a function f if, first of all, it's in the domain of f and the derivative at c is 0 or the derivative at c does not exist. So we should go about finding the derivative. So let's start with the first one. And on that one, we need to apply the quotient rule. So the derivative, f prime x, is going to be derivative of numerator is e to the x, leave the denominator alone, minus leave the numerator alone, and the derivative of the denominator is 1. And then we divide by x minus 1 squared. And we could rewrite that as e to the x times x minus 2 over x minus 1 squared. I just pulled the e to the x out of the x minus 1 and the 1, or you can multiply it through if you want and collect like terms. So now I need to figure out where this is 0. So f prime x, it's rational, so it will be 0 when the numerator is 0. So that's going to be when e to the x times x minus 2 is 0. Of course, e to the x is never 0, so this is going to be 0 when x minus 2 is 0 or when x is 2. And of course, 2 is certainly in the domain of the original function. The only thing that's not in the domain is 1, right? So that will be a critical number. Now, you might wonder about the points where f prime c does not exist. Well, this doesn't exist, or it's undefined when x is equal to 1, but 1 is not in the domain of the function, so that is not a critical number. So I just made a note of that. So the only critical number of this function is x equals 2. Now let's find the critical numbers of this function. So first, let's get the derivative. So f prime t is going to be 3/4 t to the 3/4 minus 1, which is going to be minus 1/4, minus 2 times 1/4, which is 1/2, t to the 1/4 minus 1, which is minus 3/4. Now, I need to set this equal to 0. So we should rewrite this and get a common denominator. That way we're less likely to make errors. So let's rewrite this as that one is 3 over 4 t to the 1/4. This one is 1 over 2 t to the 3/4. Now, what is the common denominator? Well, if I multiply t to the 1/4 by t to the 2/4 or t to the 1/2, I get t to the 3/4. And here, if I multiply this by 2, I get 4. So my common denominator is going to be 4 t to the 3/4. So I've just written this to indicate what I'm doing here. And so when I multiply that, I get 3 t to the 2/4, which we should really write as t to the 1/2. And on the denominator, I get 4 t to the, again, that's 1/4 plus 2/4, which is 3/4. And over here, I get 2 over 4 t to the 3/4. So that's my common denominator. So I have 3 t to the 1/2 minus 2 over 4 t to the 3/4. And I want the critical numbers. Now, the critical numbers will occur at points in the domain where the derivative is 0 or undefined. So first, let's think about where this derivative will be 0. And that will occur when the numerator is 0. So f prime t is 0 when 3 root t minus 2 is 0, or when the root of t is 2/3. And that occurs when t is equal to 4/9. And that's certainly in the domain of the original function. Now, f prime t is going to be undefined when the denominator is equal to 0. So when 4t to the 3/4 is 0, and that is exactly when t is 0. Now, let's go back up to the original function. So this is the original function, and certainly 0 is in the domain of this function, and so is 4/9. So I have two critical numbers in this case. So my critical numbers are t equals 0 and t equals 4/9.